Good afternoon, everyone. I know it's lunchtime and I'm the last speaker before everyone heads out to lunch, and I see a lot of restless faces, so I'll try and keep it crisp but also engaging. So far we've heard a lot of interesting things about technology, data, digitization, analytics, and all of these very interesting concepts. A couple of years ago when I started Einsite, we were also very excited about these concepts, but then we realized that having too much information is sometimes just as bad as having too little. So today I'm going to talk about information overload and how to actually make sense and make use of all the data that you're collecting. So just to give you a background, Einsite is a startup which we started a couple of years ago. I started with my brother Rajiv, who was the closing speaker of the previous session, and we started this with the goal of trying to digitize some of the construction operations to improve how projects are being executed and managed. And as a disclaimer, we decided to focus specifically on the heavy civil construction industry. So these are projects like highways, irrigation canals, large infrastructure projects, which are highly mechanized, but they're still industries where the data is not being used. So this company also, our startup, we got some funding from a prominent US VC called KPCB, and we also have advice from the Stanford Civil Engineering Department, where I actually studied my undergrad. So in a nutshell, I think this is something everyone's very familiar with. Most of the industry around the world is still depending on paper reporting. So the data that everyone's talking about right now, it still comes in the form of handwritten reports. And then I think a lot of people in the industry have tried to digitize parts of this data collection, but we believe it's still fragmented in many ways. And this is, I think, the issue that we're trying to solve here at Einsite by integrating the project and equipment management on a digital platform. So before we go ahead, to talk about the amount of data that's generated, so this is a very famous picture of Bill Gates sitting on a stack of papers. I think this was in the 90s. So he wanted to demonstrate that all the papers that he was sitting on, all of that information can be contained in one CD drive, one CD that he's holding in his hand. Today on the internet every day, we're actually producing enough data to fill up 250 million DVDs. And as more and more of these so-called IoT and industrial IoT devices come online, we're going to be bombarded with more and more information, which I believe we don't really have an effective way of handling. As I mentioned, when we started Einsite a couple of years ago, we thought that let's try and get information from all the different elements of a civil construction project. And then we thought that once this information comes into a centralized platform, all of our problems would be solved. We would know exactly what's happening on the project. You can keep track of everything, and then all your management issues would come down. We actually deployed IoT devices into each of the different types of equipment you see on the slide. And depending on the type of equipment, we actually got different kinds of data. From the concrete plants, we got details on the entire production of concrete. From the trucks, you get the location and activity status and so on. We thought that once you get all of this operational data online, we should be able to use it in some interesting ways. But then we realized that the information from each of these different sources is living in its own silo. It's very fragmented. And sometimes all of this information is a bit too overwhelming for project managers. So I think a lot of the previous speakers have talked about a great vision for the future of this industry. But what I'm trying to talk about today is the ground realities that we realized when we actually set up technology on a highway construction project. So for the example, I'm taking data from a live pilot project that we did, but it's highly simplified. So for the ease of understanding of the audience, we've decided to simplify the example into basically the GPS coordinates that we get from 4 different pieces of equipment. GPS tracking is something that people have been talking for more than a decade. And there are a lot of potential uses for it. But just using the GPS, we don't actually have that much information. So I've taken 4 of those coordinates and plotted it on the map there. So this is actually a highway construction project in Haryana. But with just GPS, you don't really understand what you're supposed to do with this information. So in this example, as we go forward, I will add more and more levels of context to this basic information and show you how you can come out with insights by adding context. So the first level of context we'll add is what we call the asset codes. So based on the asset codes, we know that we're now looking at a concrete plant, a truck, an excavator, and a paver. And someone who's from this industry immediately already understands something, right? He might infer that the paver is going to do a concrete job with concrete produced in the plant, and the truck is going to be used to transport that material. And the excavator, for example, can be used to prepare the site for the next piece of work. Next, what we can add is what we call the transaction packets. So once we get the details of the transaction in the plant, you know that the plant is producing 270 cubic meters of concrete. And then based on another piece of information, which is the project plan and design, we know that this much concrete translates into a 100-meter pavement. Next, we also add the location, the local coordinates of this project design. And by doing so, we also know in the local coordinate system where all of this is happening. So in this very simple example, we started with raw data, which is very difficult for anyone to even use or consume. And then we added various types of context. So this could be the asset codes, the work codes, the project design, and so on. And just by adding this little bit of contextual information, you're able to come out with a very neat set of insights. So you know that there's a pavement of 100 meters in kilometer number 25. You know that kilometer 17 is going to be the next location of work because the excavator is doing its work there. Of course, this is a highly simplified model example, and in our product we actually get a lot more data and a lot more context, so we can show you even more insights. But I just wanted to show on a first principles basis that just having data from different sources would actually not solve too many problems. In fact, it might create new ones. And I think the solution is to tie together data which is fragmented in different silos. The only way to tie it together is using context. So compared to the earlier diagram you saw, there's a slight change here, but it's a very significant change. We still have IoT devices and data coming in from all of the different equipment. But then before we present it to the end user, you have to add the contextual data from the project and industry, which is what I demonstrated in the example before this. And in doing so, we actually have created an integrated project management tool, which lets you basically understand everything that's happening on your project. And more importantly, it lets you look at actionable insights. So I believe this is should be the primary focus of any technology in this industry, because people from this industry already are dealing with a lot of problems on the ground. They don't want to be looking at their phone or computer for hours on end just to figure out what they should do. So if you give a project manager information and he doesn't know what the next step is, then we have failed. So what we try to do is provide actionable insights, which would be a simple list of insights on which he can immediately take some action. So for example, if he saw that in a given pavement of concrete, he's supposed to use his paver for 5 hours, but it's being used for 8 hours. So those 3 extra hours are eating into his profit margin. So he immediately knows that when I do a pavement tomorrow, let me make sure that I don't use it to overuse it. Because overuse of your equipment would lead to a lot of different problems that are not very easy to kind of handle if you're not using a digital reporting tool. Earlier people, as I showed in one of the initial slides, earlier all of this information was coming in through paper forms. So we have already come to the stage where we're digitizing some of these data entry processes. But still, I feel that most of the data that you see is in different silos, and it needs to be tied together using context. So this is an example of what we do. As I mentioned, we track using the IoT devices, a batch of concrete as it's created and as it's transported to the work location. You also verify the actual quantity using information from a weighbridge. And by doing all of this, you get a real-time information on the usage and location of both your material and equipment. And the idea is, if you can compare this utilization or usage to your plan or your expectations or your norms, you should just be able to get either a green signal or a red signal. If it's green, you continue doing your job. If it's red, then you investigate further and figure out how you can improve what you're doing. So I think the conclusions are quite simple, and compared to some of the earlier speakers who presented a lot of interesting new technologies, what I wanted to focus on was how do we actually make use of this in a tangible way. So I think the few conclusions that we have had is that first you have to integrate data from different silos, but then the data is still going to be useless to a project manager unless you add the context. So I think the good news for people who are from the traditional construction background is that all of the fancy technology that you're hearing about today is useless without your domain knowledge and your industry intelligence. And in the example that we showed, this domain knowledge is in the form of your work codes, your project plan, your equipment usage norms, and things like that. So these are the conclusions that we had in over the last 2 years of running these pilot projects. And I think we're short on time, so I think I can take any questions offline. But otherwise, I'd like to thank CII for the opportunity of speaking here, and I look forward to discussing this with some of you afterwards. Thank you.